So now let's go through an important topic called color temperature. So what is a color temperature? The color temperature of a light source is the value of the absolute temperature of a black body radiator when the radiator chromaticity matches with that of a light source. What do you mean by that? Let's see the example in the figure over here. I have taken a black body and when I heated it to 900 Kelvin in the first figure, it turns to be red. Now when I increase the temperature to 750 Kelvin, now the black body turns into yellowish dark red. Now when I further increase the temperature to more than 3000 Kelvin, it changed its color to yellowish white. Now if I further increased its temperature to 500 Kelvin, now the color changed to bluish white. Right, so what is the color temperature in this? Okay, so in layman terms, what is the color temperature? So different light sources produces different colored light. Say for example, a candle will produce a reddish light, whereas a midday sun will appear in the form of a blue tint. So all these different colors should have to be expressed by some numbers, and that number is known as a color temperature. Did you understand it? So for each and every color there will be a number, and that number is called color temperature. So higher color temperatures means 5000 Kelvin or more, they are termed as cool colors, and the colors will be in between blue and green. And lower color temperatures means they will be in between 2700 Kelvin to 3000 Kelvin, and we call them as warm colors, and the colors will be in between yellow and red. As you can see in the figure over here, at 2700 to 3000 Kelvin, we can observe a light with low color temperature, and that light is a white light, of course, but it's a warm light. It appears a slight yellowish in color, and when you increase the color temperature to around 4100 Kelvin, then you can observe a normal white light. If you increase the color temperature further, you can see if you increase the color temperature to more than 5000 Kelvin, then you can see a light called a cool light, and this cool light will be used for reading and for other activities. So as the color temperature increases, you can see different kinds of light, and all these different kinds of light will have a number, and that number is called color temperature. Now let us see one more important topic in lighting called color rendering index, CRI. So what is a CRI means? The color rendering index is a qualitative measure of the ability of the light source to reveal the colors of various objects faithfully in comparison with the ideal or natural light source. A color rendering index is a qualitative measure for the ability of a light source to reproduce the colors of various objects in comparison with the ideal or natural light source. So for example, you can see an apple, its original color when CRI is 100 at a color temperature of 2700 Kelvin is, you can see the color of an apple in the first figure. Now that is a natural color. When normal daylight or white light falls on it, the apple looks in that color. Now I have kept the apple under the light source. So initially, when I keep an apple under the sun or a natural daylight, I can see the color as it in the first figure. In that case, the color rendering index is 100. That is, it is faithfully reproducing the actual color of the apple. Now, when I take the same apple and kept it under some light, a light source, so whose color rendering index is 90, then the actual color of the apple will not be reproduced in this particular lighting. I'll take an apple and I'll keep it under the sun or a natural daylight, and I'll take a photograph of it, and that photograph will appear as it is in the first apple, right? Now, that photograph will reproduce the actual color of an apple, and when any light source will reproduce the actual color of any object, it is nothing but a CRI of 100. That is faithful reproduction of an actual color of object. Now I take a same apple and kept it under a light source which is having a CRI of 90. Then I clicked a photograph of it, and that photograph is the second apple. Now you can see the difference between first apple and second apple. You can clearly see that the original color is not reproduced. Now if I take the same apple and kept it under a light source which is having a CRI of 80 now, and I take a photograph of it, and that apple is the apple number 3. The color reproduction is further reduced. Now I take the same apple and kept it under a light source which is having a CRI of 70, and then I clicked a photograph, and that one is a 4th apple. Now you can see the faithful reproduction is further reduced. So as the color rendering index decreases, the actual color will not be reproduced by the object. So for every color in the universe, there is one particular number, and that number is called the color temperature. As you can clearly see in the picture here, the clear blue sky is having a color temperature of 10,000 Kelvin. So the 10,000 Kelvin corresponds to the color on top of this chart. As you can see over there, the top of the chart corresponds to clear blue sky, and its value is 10,000 Kelvin. And you can see when you come down, there is a cloudy sky, and this cloudy sky is having a color temperature of 6,500 Kelvin, and the color which corresponds to that 6,500 Kelvin, as you can see in the picture. If you come down still, then you can see there is a midday sun, and this midday sun is having a color temperature of 5,500 Kelvin. That is, the color corresponds to the midday sun is 5,500 Kelvin. If you still come down, you can clearly observe there is a moonlight which is having a color temperature of 4,000 Kelvin. If you still come down, there is one more color which corresponds to morning or evening, and this color has a color temperature of 3,500 Kelvin. If you come down, there is a light bulb, incandescent light bulb, which will give you yellowish color. So that has a color temperature of 3,000 Kelvin. So that color corresponds to 3,000 Kelvin. If you still come down, there is a sunrise and sunset. So the sunrise and sunset will appear in the color as shown in the figure, and that color has a color temperature of 2,500 Kelvin. And finally we have a candle flame. When you light a candle, it will give some yellowish color flame, and that flame has a color temperature of 1800 Kelvin. So this 1800 Kelvin corresponds to the color of a candle flame. So for every color in the universe, there is a value, and that value or a number is called color temperature. You observe now, we'll talk about low color rendering index. What is this low color rendering index? Take an example of an apple at the top of this figure. So whenever a sunlight or a natural light fall on the apple will reflect only the red light, and remaining all the other lights it will absorb. So that is the reason why the apple looks red in color. So for the observer, the apple looks red in color. The same apple, so the natural light source has a color rendering index of 5,000 Kelvin when you saw the red color of the apple. Now you use the artificial light which is having the same color temperature of 5,000 Kelvin, and now when you observe and when you make the light of this artificial light fall on this apple, this apple will reflect some color, and that is the reason why, and that color is, you can see it's orange. It's not red, it's orange. So what do you mean by that? So this light source is not faithfully reproducing the actual color of the apple, that is red. Instead, it is giving another color, that is orange. So what can you say that now? So what can you conclude from this? So this light source is having a low color rendering index. So it is not good at faithfully reproducing the actual color of an object. Now let's talk about high color rendering index. So the same example, I'll take an apple and I make the white light or the natural light which is at a color temperature of 5,000 Kelvin. I made it fall on this apple, and now this apple will reflect the red light, and that is the way the apple looks red in color to an observer. Now when the same apple, I'll take it into a room and I will use an artificial light source which is having the same color temperature of 5000 Kelvin. Now you can observe that the apple looks red in color to the observer. That is, it is reflecting the red light. And what is the conclusion that we'll get from this slide? That the light source is faithfully reproducing the actual colors of the object. And that is the reason why this light source is having high color rendering index. So now let's see the color rendering index chart. So in this chart, we can clearly see that if the color rendering index is in between 0 to 60, in the diagram you can see, if it is in between 0 to 60, you call it a poor light. If it is in between 60 to 85, you call it a good color rendering index. If it is in between 85 to 100, or if it is above 85, you call it as a excellent color rendering index. So again, this poor range, which will be in between 0 to 60, is further classified into two different subcategories. If it is in between 0 to 20, you will call it as a perfectly bad. If it is in between 20 to 60, you call it as a average. If it is in between 60 to 100, you call it as a good or excellent. Now you see the chart here. Daylight or a natural light is having a color rendering index of 75, which is termed as a good. So daylighting itself has a color rendering index of 75. And you can also see here, cool white is having a color rendering index of 60, whereas warm white is having a color rendering index of 55. So this cool light having a color temperature of 4100 to 5000 Kelvin. Whereas this warm light is having a color rendering index of 2700 to 3500 Kelvin. Now you see the table over here. What are the sources that have good, average and bad color rendering index? That is, what are the light sources which have good, average and bad color rendering indexes. Now you can see from the top, daylight, incandescent light, metal halide and some good LEDs have a better color rendering index in between 60 to 100, and that's why you term them as excellent or good. On the other hand, if I take a high pressure sodium vapor lamp, the color rendering index under this lamp is not that fruitful. So it is not exactly reproducing the actual colors of the object, and that's why it is termed as an average. And that is, it is having a color rendering index in between 20 to 60. And now we will see the bad light sources. So low pressure sodium vapor lamp is a very bad source of light, and it does not actually reproduce the actual color of the object, and that is why it is termed as bad, and it is having a color rendering index in between 0 to 20. So the light sources which are having very good or excellent color rendering indexes are daylight, incandescent lamp, metal halide lamps and LEDs. And the light sources which are having average color rendering index is high pressure sodium vapor lamp, whereas the light source which is having very bad color rendering index is low pressure sodium vapor lamp. So now let us discuss what are the different types of lighting. So there are three different types of lighting that work together to light your home. And what are those? The first one is a ambient lighting, second one is a ascent lighting, and third one is a task lighting. So a good lighting plan combines all these three types of light to light an area according to the function and style of the home. The first type of lighting is a ambient lighting. So what is an ambient lighting? The ambient lighting means the light that is already present in the scene before any additional lighting is added into the room. This lighting will be provided through windows or through doors or through open spaces, and that is the lighting which is naturally available in the room before you artificially illuminate a room. It is usually referred to the natural light either coming from outdoors or coming through windows, etc. It can also mean artificial lights such as normal room lights, as you can see in the picture over here. So in the picture you can clearly observe that the light is coming from the windows as well as there is lights which are there in the room, and the lighting which is coming from these two things is nothing but an ambient lighting before you artificially illuminate a room separately. And the second kind of lighting is Ascent lighting. The Ascent lighting is a directed light at the things that you want to be illuminated. For example, artwork, pottery, plants and so on, to achieve a desired effect. You can see in the figure over here, there are some glass bowls or a trees which you want to expose, and you need to place a light on top of it so that that particular items will be exposed, and this kind of lighting is called an Ascent lighting. And this Ascent lighting will help you illuminate the pieces you want on display while shadowing the other areas. Now you can see in the figure over there, some of the cupboards are illuminated and some of the cupboards are shaded. That means you wanted to show the cupboards, if you wanted to display or if you wanted to highlight or expose some objects in that particular cupboards, you need to go for Ascent lighting in that particular cupboard while shadowing the other cupboards, so that the observers will have a eye grabbing, so automatically it will grab the observer's attention. As a general rule, the effective Ascent lighting requires the installation of 3 times more lighting than the ambient lighting generally provides. So you need to provide 3 times more lighting to that particular device you wanted to expose. And the third type of lighting is a task lighting. The task lighting illuminates the tasks a person carries out in a given space, such as reading, cooking and computer works. You can see in the picture over here, if you wanted to have light for working on your computer, you can just provide a light at top of your computer. And this kind of lighting is called a task lighting. A brighter light is required in a smaller focal point of the room for this sort of tasks. As you can observe here, there is a dining table over which you have a task lighting. So we should use a brighter light in a small focal area to identify the task lighting effects. So altogether, all the 3 types of lighting, that is the ambient lighting, Ascent lighting and task lighting, will be used in our day-to-day lives, either singly or in combination, in order to get the desired effect. So all these 3 lighting schemes should be properly used in order to get a beautiful view of the equipment, objects, as well as a more efficient lighting, or to get a more efficient lighting. Now coming to the next topic, it is light fittings or luminaries. So what is a luminary? A luminary is nothing but a light fitting. A light fixture or light fitting or luminary is a complete light unit. Lighting unit is a complete lighting unit that contains an electric lamp that provides illumination together with the parts that distribute the light and position and protect the lamps and connect the lamp to the power supply. So along with the lamp, you require 3 more devices. What are those? A device to distribute the lamp, a device to place and protect the lamps, and a device to connect the lamp to the electrical supply. All these 3 along with a light bulb, you call it a luminary or a complete lighting system unit. So the luminary's function is to direct the light to appropriate locations without causing glare or discomfort. As you can see in the pictures over here, you can see 2 different types of luminaries used in these 2 pictures. The first one is for the tube lights and second one is for the incandescent light bulbs or LEDs or CFLs. So these are the luminaries which are used in our day-to-day life. Now let's discuss the next topic, that is flood lighting. So what is a flood lighting? The flood lighting means flooding of large surface with lights from a powerful projectors. So what is it? Spreading of light over a large surfaces using powerful projectors is termed as a flood lighting. As you can see in the picture over here, the floodlights. So generally, whenever we talk about floodlights, we talk about stadiums. Now the IPL matches are going on, you can see the floodlights. So under the floodlights, players are playing the matches. So these floodlights will spread the light over a large distance by using a powerful projectors. So for this flood lighting, it is necessary to concentrate the light from the light source into a relatively narrow beam. So the particular type of reflectors and its housing used for concentrating the light into narrow beam is known as a floodlight projector. So how we will project a narrow beam of light? The narrow beam of light will be produced by means of a device called floodlight projector. So the floodlight projector must be robust and it should be waterproof. Even during the rainy season, the lights cannot stop producing the flood lighting, or even when there is a dew, the lights should still glow. We can see it in the cricket matches, even though there is dew. So in the IPL 2020, we can see it now, even though we are playing in the Gulf countries where the dew is very, very high, the bulbs or the floodlights still work even under the dew conditions. So the floodlights should be waterproof and they must be robust. The flood lighting is employed to serve one or more of the following purposes. The first purpose is aesthetic flood. The second purpose is commercial or industrial flood. And the third one is advertising flood. And let's see one by one. Aesthetic flood. So what do you mean by this aesthetic flood? This aesthetic flood will be used for enhancing the beauty of a building at night, such as public place, ancient buildings and monuments, religious buildings on important festival occasions, etc. Say for example, you can see this one. There is a city which was on the bank of a river and that got illuminated to showcase it the beauty of that city. And that is the purpose of an aesthetic flood. You can also use this aesthetic flood. You can also find this aesthetic flood during at Taj Mahal at night, at Charminar at night, as well as Tank Bund, the Buddha Stupa at night. You can find this aesthetic flood to illuminate a particular building or an object. We use this aesthetic flood lighting. And the second purpose of this flood lighting is industrial or commercial flooding. Flood, that is for illuminating the railway yards, sports stadiums, car parking, construction sites and quarries, etc. You can see the picture over there. A cricket ground was illuminated by a flood lighting system, and this is called industrial or commercial flood. And the last purpose of this flood lighting is advertising flood. So this advertising flood is used for illuminating the advertisement boards and showcases. You can see in the pictures over here, there is a advertising holdings which are getting illuminated by means of a flood.